All right, today, this is the last lecture before Christmas vacation.
We have a test?
What are we doing on Thursday?
I do, yes.
I just sent an email this morning. Somebody better tell him what was on the email this morning.
So we have a test after Christmas break.
What?
The test is gonna be after Christmas.
Oh yeah, okay. Go try to take it after Christmas.
The test is on Thursday.
No, there's something about notes. You can have notes.
No,
He's gonna give us.
I'm gonna give you a note sheet.
No!
Yes, it has all the notes on it. No, you know, like all of these things that are on the top here, I just put it all on one paper. I don't want none of this like, oh, I don't know how to do integrals, so I'm gonna put that on there.
Wait, but do you at least give like what the equation is for?
Like, did you just copy and paste those?
Yeah, I just copied and pasted those.
So you know, like if it's in a surface area kind, then you say this is the surface
Oh
area.
no, I just give, no, you guys are lucky you're even getting formulas.
Can we have a 1/8 of a paper?
No, I'm giving you a whole sheet.
Oh.
Why, do you want me to give you the paper so you can see it ahead of time?
Yes.
Wait.
Oh gosh. I'll think about it. Okay, this is the last lecture right here. So divergence. Divergence measures the change in density of a fluid flowing according to a given vector field. So to compute divergence, it's really easy. Look over there.
Far distances.
Oh gosh. Why is it on this one?
Yeah, we did this.
7.
Great.
Homework.
Yeah.
When is the test?
Wednesday.
Okay, now we're gonna do curl then.
Oh.
Curl measures the rotation of a fluid flowing along a vector field. Okay, now to compute curl, that actually is not correct because there shouldn't be an equal sign there. But that is like a mnemonic to help you remember what curl is, because otherwise the formula is very difficult, as you'll see. So to compute the curl on a vector field, all you have to do is, okay, what does it say? Now it says equal, but like I said, it's not really equal. IJK, kind of like a cross product, except it's not. Partial with respect to x, partial with respect to y, partial with respect to z, and then v1, v2, v3. Those are the components of the vector field. So if we compute this determinant, that is the actual curl of the vector field. So if we go across, expand across the first row, you're going to get I times. If you cross off the row and column, then you get this times this minus that times that.
Yeah.
So when you go this times this, it's not actually this times that. It's the partial of V3 with respect to y minus the partial of V2 with respect to z.
Why is there 2?
That's not 2, that's the partial. That's the del. That's the del.
Wait.
It's not a 2, it's a del.
Is partial respect? What's the difference?
Between a 2 and a del.
Multiply. Didn't you just multiply that?
Yeah, okay, how do you compute a determinant?
Yeah, you multiply.
You go this times this minus that times that, right?
What is
No,
the
but there's no
difference?
such thing as like a del y.
Yeah, there's no such thing as this.
You need a.
So when you multiply times this, the V3 goes on the top. This is a mnemonic to help you remember this formula.
You need a
Oh, because the
function.
F is gone.
Yeah.
Oh.
Okay, and then minus J, right? And then you go this times this minus that times that. So partial of V3 with respect to x minus partial of V1 with respect to z plus k times, and then you go this times this minus that times that. Partial of V2 with respect to x minus partial of V1 with respect to y. So this is the actual computation of the curl. You really want to memorize this? No, it's much simpler to memorize that, but you don't even have to memorize because you're going to get a sheet with all the formulas on it. Okay, so can I assume that you guys can compute the curl?
Yeah.
Easy.
Okay. Yeah. Okay, but now, to Stokes' theorem, if V, the vector field, has continuously differentiable components on S, then to compute this, what was this again?
Huh?
What is this from a previous section?
It's not F, wait.
What is this? Come on.
Flux. No.
Is that flux? V of R of T. Yeah, there might be flux, yeah?
What's flux?
Isn't this flux?
That's
I think that is flux.
I
Then you
do.
could just use this to compute it. The curl of V dot N d sigma. Okay, so we know how to compute the curl, then now you gotta dot it with N. And what is the N again? Remember from a previous homework? It's the upper unit normal. So whatever the surface is, like the one you're gonna get, look, the surface is a plane, 2x plus y plus z equal 2. Isn't this a plane?
Yeah.
In fact, why don't we sketch this plane, just for funsies? What is the x-intercept? 1. The y-intercept is 2, and the z-intercept is 2. I think I graphed this on the thing, right? Right, so this is the plane right here, right? On the portion of the plane in the first octant, which is this, traversed counterclockwise. So the upper unit normal would be a vector that's perpendicular to this plane, like that. And it has to be a unit vector. So what vector is, if this is the equation of the plane, then what's the perpendicular vector? 2, 1, 1, right? But we need it to be a unit vector, so what is the length of this vector? Root 6. So if you multiply by that, that'll become a unit vector. So the upper unit normal would be 2 over root 6, 1 over root 6, 1 over root 6. Upper because it's pointing upward, you know what I mean? So what you have to do is you have to take the curl and dot it with that normal vector right there, and then you gotta go d sigma. And then over here it says use d sigma to be root 6 dx dy. So you just substitute it in, and then you have a double integral to compute.
How do you know the range?
Smash it down onto the xy plane, right? Right here. So your omega region, when you smash it down onto the xy plane, is that region right there, right?
So why is it not a triple integral?
Because it's a double integral right there. Because you're computing work, not work.
What?
No, flux. Flux. It's a double integral. So here, if you want to look at it from above, I think I drew the same picture in the video. So what was the x-intercept? 1, and the y-intercept was 2. So if you look at it from above, this is your omega region right there, right? So you can go y goes from y equals 0 to y equals, what is that, 2 minus 2x?
Yeah.
Is that right?
No, yeah.
And then x can just go from 0 to 1. So the hardest part about that is you just gotta compute the curl, but then you compute the curl by doing this, right?
Is there a difference if it traversed clockwise?
Well, counterclockwise is in the positive direction, right?
Or what?
Just like
Oh,
in trigonometry, counterclockwise is positive, right? And just like right-hand rule, right? Counterclockwise it comes out, clockwise it goes in, right? Counterclockwise is the positive direction for mathematics.
So what does the result mean?
Well, I guess it computes the flux. That's what you guys are supposed to come in. I can show you guys how to compute this integral, but you gotta tell me what it is. I had a D in physics, I keep telling you.
I don't well do that.
Who are the people in AP Physics C again? So did you guys ask Doc about flux? Why not?
Doc's scary. Well, ask him tomorrow.
How about in the book?
Oh.
Is there like a chapter on flux?
Oh, that's Mr. Kohara.
I don't think that's flux.
What is it then?
I don't know. Because flux doesn't have that curled part. Like flux is just a.
Okay, then it's not flux, so what is it?
Yeah.
So it's the vector field of R.
Distance of the flux.
No.
Yes.
How they work? Because it's like.
Doesn't work like force that like.
V of R of T dot R prime. R prime though, right? I don't know.
Line integral.
But work is just one integral.
It's
Okay, wait. You guys have an iPad in front of you. Why didn't you type in, what is Stokes' theorem used for?
See, rate of flux.
Rate of flux.
We're not going anywhere till somebody Googles,
See ya.
what is Stokes' theorem used for?
Can be used to turn surface integrals through a vector field into line integral.
And a line integral is to compute work then, right?
I guess so.
So isn't that work?
Yes.
So we're computing work then. The work of what though?
The
The flux.
flux.
That can't be work because work is like.
What?
Okay.
It can't be work.
Because
Wait.
work would be like the force field, but this is like the.
Well,
Vacuum.
V just is the force.
Oh,
It's
maybe.
fine.
Like, it
Stokes'
doesn't tell you
theorem
what V
relates
is,
the
it just
flux
says V.
integral over the
V
surface
stands for
and line
force.
integral.
Oh my god, this is. Okay, you're lucky you don't have to interpret what the integral is doing, because I don't even know.
What is it for? What is it for?
You just have to compute these integrals.
Oh no, it says Stokes'
It
theorem.
is work.
I knew it.
Just replace V with F, and then it's good.
Okay, then it's work. So the work of what though?
The flux.
That the vector field does on the
Plane.
The vector field does on
The
the fluid.
liquid.
the fluid that flows through the surface. Because it's going through the surface, right?
Easy.
Okay, well.
Easy.
Okay, wait, I need help on econ.
Wait, we are not done yet.
Oh,
Okay, look, I'm gonna show you. Wait, let me turn this off first. I'm gonna show you the sheet that I'm gonna give you.
Can you take a picture of it?
Okay?
oh. Yes,
Or-
please.
Wait, what is it?
And if it's not good enough, too bad.
For the lunch point thing. I have so many things wrong and I'm so confused.
Wait, we're not done yet. We gotta play a game.
Yeah, I know.
No, we're not gonna play a game. We'll play it tomorrow.
What?
Oh yeah.
I just made one here. Okay, wait. I'm trying to think. It's a thwarting me here.
Dylan,
Shh.
See you dancing to energetic.
that's not doing it.
Dude, I can promise you right now. Stop laughing. No, stop laughing. Stop laughing.
Okay, this is the note sheet I'm gonna give you.
If you memorize integrals, then you don't have to show work.
Yeah?
Really?
Yeah, I
Okay.
mean, yeah.
Well, I expect you guys to memorize secant cubed already.
Okay.
If you don't have secant cubed memorized, just go home, cook rice, right?
Tangent minus?
ln of secant plus tangent
What
of.
happened?
Oh, is it minus or plus?
Okay, here, look.
One half
Work, the work integral, f of r of t dot r prime of t. Work done, so it basically, I just copied and pasted all that stuff on the top. Green's theorem,
Wow.
surface area formula, flux across S, the divergence of a vector field, the divergence theorem, curl, and oh,
Oh, still there in your brain.
Huh?
That is number
Nothing.
one.
nothing. Nothing.
I didn't see it.
That's right, nothing to see.
You saw it.
Well, you saw the first problem.
I legit don't remember.
You saw the first problem.
I remember.
No, I literally don't remember.
Oh man.
Anyway, that's what's on the note sheet.
How you knew?
No,
You weren't
there's no
paying
way it's fine.
attention.
So basically,
No.
are you guys watching on the video? Everything on the top of the thing, I just copied and pasted onto one.
Wait, now how do you know which theorem to use then?
Okay, that,
Wait, now I'm lost.
no.
How do you know?
Cause you did the homework, that's how you know.
That's tough.
You guys are supposed to be the top math students in the school.
Come on, guys. Come on.
Okay, divergence says divergence. But if it's
Go for it.
divergence, will you say divergence?
Come on.
He'll say like calculate the divergence.
Yeah, I think so.
Yo,